mode.
Good afternoon or good morning, everyone. Alan Schimmel, Editor-in-Chief of DevOps.com, and welcome to another DevOps.com webinar. We're just here at the top of the hour, and we are going to give a minute or two for late arrivals to log in, as they always do. While we're waiting for the rest of us the rest of you to log in, I just wanted to quickly go over the GoToWebinar control panel that most of you should be seeing on your screen. If you notice, there is a section of the control panel marked questions. We've set aside time at the end of today's webinar for questions from the audience for our panelists, and you can type your questions in there at any time. You don't have to wait till the end for the question section to type them in. You type them in and we'll try to get to as many of them as possible. If we can't get to all the questions, as is sometimes the case, we will try to answer them later on, and the answers will be posted on the DevOps.com webpage, which hosts this webinar. And I know one of the questions always is, will the slides and a recording of this webinar be available? And the answer is yes, of course. We usually post them to DevOps.com within 24 to 48 hours after the conclusion of today's webinar. So questions can go there. There is a chat session if you need to reach out. The chat is monitored by our engineers, and today we're lucky to have Jules Lewis as our managing engineer for the webinar. So if something's matter, you have a question of a technical nature, Jules is monitoring chat, as all of the panelists are. Other than that, I think we have a really great webinar lined up for today, and we're about 2 minutes after the hour, so we're going to kick it off. Today's webinar, if we can go back to the first slide, please. Today's webinar is Enabling DevOps and Containers on VMware with Nirmata. And very thankful to Nirmata for sponsoring today's webinar. And they are partnering with VMware, so we will be having a great presentation. Our presenters today are Paco Gomez, Senior Solution Architect of VMware, Thirupati Panyala, Director, IT Cloud and Mobile Apps Dev of VMware. And Thiru, if I messed up your name, I apologize. I do the best I can. But our first speaker is actually Jim Bagwadia. He's the founder and CEO of Nirmata. Before we hand it off to Jim, obviously containers is one of the hottest topics out in DevOps in general, and specifically IT generally. And how containers interact with virtualization of VMware is a very hot topic. I think we're going to have a great event. I remind you, you can type in your questions at any time. Don't wait till the end, because half the time we forget them. With that being said, Jim, I'd like to hand it off to you. Are you there?
Yes, I am. Thank you, Alan.
Okay.
So, hi, everyone. This is Jim Bagwadia, and just to quickly introduce the agenda and the flow for the webinar, what I'll do is I'll start by describing the overall problem and challenge that we're seeing today in the DevOps space. I'll give a brief background and overview of Nirmata. Paco is going to talk about VMware vCloud Air and how it enables DevOps with containerization. Thiru is going to give us the customer perspective and show how his team embarked on a DevOps and containerization journey and the goals and milestones they've achieved with that. We'll also do a brief demo of the Nirmata solution on vCloud Air, and then we'll do questions and answers at the end. So to start with, I just want to kind of lay the kind of foundation for what we are seeing in the space today, and part of the reason for why we started Nirmata and the problem we're trying to solve. So in the last couple of decades, we've seen this incredible transformation in enterprise IT, where very rapidly with pioneers such as VMware, the entire data center has become software defined across network, compute, and storage, And we are moving now very rapidly to cloud, whether it's private cloud or public cloud, being the go-to platform for new applications and new services that businesses are delivering. In this decade, what we're now starting to see is the next evolution, or revolution, if you will, which is the rise of what we think of as application services. So in the last decade, we solved a lot of fundamental infrastructure problems and made it really easy and fast to enable infrastructure services. And now with microservices style architectures, as well as containers, we're addressing the next set of issues, which happens to be in the application space. So today, you see businesses and the pioneers in the space being able to deliver applications in minutes rather than weeks or months, where small changes can be pushed into production data centers very rapidly. And we're also seeing the shift towards dynamic applications running on dynamic infrastructure, whereas previously we had applications running on fairly static or pre-provisioned infrastructure. So all of this is great, and really, if you combine it with the rapid innovations we're seeing in software tooling and software development itself, the development cycles and the release cycles keep getting shorter and faster. But what this also does is there's significant complexity that's being introduced on the operations side. First off, with containers and microservices, there's a lot more moving pieces. Every system that we build nowadays happens to be a distributed system designed for the web and internet. And all of this, again, comes together and adds a lot of operational complexity. And what we've seen is there's been several attempts at various types of tools, or there are several point products which have been built. But what's been missing so far is a cohesive set of functionalities to help customers operate and manage these type of next generation applications. So introducing Nirmata a little bit, and then I'll talk about what we do to solve this problem. So we started Nirmata, my co-founders and I, Ritesh Patel, myself, Damien Toledo, we started Nirmata in late 2013, and our focus was to drive the adoption of cloud-native architectures and cloud-native applications. Although Nirmata is a fairly new company, we have decades of experience in building centralized management systems and solutions for large-scale distributed systems across telephony, data networking, wired and wireless communications. Our solution has been, we launched our public beta in early 2015, and we're rapidly gaining acclaim, both from customers as well as, the press and analysts in the industry. Our focus at Nirmata is the operations and management of containerized applications. So we believe application containers are the right and the best way to package next generation applications for multiple reasons. And what we focus on doing is across any cloud or even any connected device, Nirmata can help operate and manage this. So the solution is designed for IT operations teams to quickly be able to enable the single pane of glass across public and private clouds that their DevOps teams can then consume and use for their applications. So at Nirmata, we decided to focus on 3 phases of what we see of the application lifecycle. So on the development side, you're free to choose any language, any tool, any platform that you wish. And as long as it's packaged in a container, and our go-to-market container technology today is Docker, the Docker engine, Nirmata can then easily deploy, operate, and optimize the applications designed with these containers across any cloud. So the goal is here to provide a complete container lifecycle management solution where you have a single management and control plane. So you're not installing and operating this per cloud, but you have a single control plane that spans multiple clouds. And we also, the way we have designed and built Nirmata, it's a very highly scalable, it's a cloud-native service itself. Nirmata itself is built using microservices style architectures, is fully deployed in containers, including our backing services that we use for databases and messages. So we can rapidly scale and enable agility with our solution itself. A little bit more details on the Nirmata solution. And at the architecture level, we think of this as having 2 high-level components. So we have our management and control plane, which you interact with using a web browser or using APIs, REST APIs. And this is where developers can easily define application blueprints. And we're working here with a consortium of different vendors to create standards and for compatible blueprints across products. But once you define these blueprints, then you can also, from an IT operations side, define a very rich set of policies for how these applications should be deployed and should be managed across public and private clouds. Once applications are deployed, Nirmata really starts providing a lot of value and a lot of its features at that point, where first off, by collecting real-time analytics through the host agents that we run on every host, Nirmata has a steady stream of information across user activity, across the host and infrastructure activity, as well as what's going on in the application space, which we can then correlate and synthesize as real-time events and feedback to the user. Finally, another component on the control plane is we've designed Nirmata to be very open and very extensible. So this fits in easily into a DevOps pipeline, whether you're using Jenkins or you're using Bamboo or other tools for your build automation and build management. And you can also plug in any public or private image registry into this pipeline, and Nirmata will easily integrate into this. On the data plane side, as I mentioned, we have a host agent. And what's unique about this host agent is we have a real-time database that's automatically managed and populated in each one of these host agents, which can help with things like service discovery, load balancing, advanced functions which you would need for microservices style applications, as well as managing the container lifecycle and managing the host resources on the VM or on the physical server. We also have optional components that you can include as part of your application blueprint, like a service gateway. And this helps with the load balancing of north-south traffic. So the host agent can seamlessly load balance east-west traffic across hosts, as well as do service discovery and networking across hosts. But if you need traffic inbound, you can do this with the service gateway. So where we fit in the container ecosystem, if you will, right? So what we've decided to do at Nirmata is, again, being a very open and extensible solution. You can bring in your own infrastructure as a service. You choose which container engine you're running, as well as what type of host OS and host you want to run on. Beyond that, Nirmata provides the microservices infrastructure layer that we talked about, which is optional, as well as the resource management, policy-based orchestration, and the entire application lifecycle management that you would need as a common control plane across clouds. So just very quickly to summarize this section, our goal at Nirmata was to create an easy-to-use, very non-intrusive and lightweight managed service for next-generation cloud-native applications. The way we wanted to do this is we want to enable enterprise DevOps by building a solution that IT ops can quickly deliver to their DevOps teams without having to go through all the undifferentiated heavy lifting of managing, operating, installing this solution across any cloud. So next I'm going to hand off to Paco Gomez, who's going to talk about vCloud Air and how vCloud enables DevOps and containerization.
Thank you, Jim. If I can get control. Thank you. So in this section, I'm going to talk about vCloud Air, VMware vCloud Air. And VMware vCloud Air is one of the platforms that Nirmata has enabled to deploy their solution, the container-based solution. VMware vCloud Air is a public cloud owned and operated by VMware, and it provides an elastic infrastructure as a service for customers, which provides a common management infrastructure between the on-premise data center and the cloud data center. It provides a seamlessly network between the on-premise and vCloud Air, and full compatibility between the workloads. So the same workloads that you have on-premise, many of customers have on-premise, can be moved into the cloud and vice versa. One of the advantages of having a hybrid solution is that through the different offerings, like the private cloud, the data center the cloud that is in your data center, or whether that's a managed cloud by one of our vCloud Air network providers, or through vCloud Air, the public network, customers can extend the traditional what we call Gen 2 applications into the cloud, and enable also application and database disaster recovery by extending their applications into the cloud. That's what we call inside-out consumption. And as well as the development of cloud-native applications, the applications that have been developed in the cloud can be easily moved back into on-premise whenever that's necessary, with fully compatibility and the same common management layer. That's what we call outside-in consumption. So for what we see in our customers, the 5 use cases that our customers are using vCloud Air for, the first one is for disaster recovery. Disaster recovery is a very simple and low-cost failover and recovery solution that allows to have a secondary site on the cloud that is consuming the minimal resources and that is ready for becoming the primary site whenever a problem or a disaster happens. That's something that is enabled for our customers, and is a very simple and low-cost solution for failover and disaster recovery. Another use case is extending existing application. Traditional application, Gen 2 applications can be extended for seasonal workloads or for geographic expansion or data center transitions. And this gives our customers the agility and the CapEx savings for handling those situations. So another use case that is very common among our customers is the development and testing. So instead of using expensive and premium on-premise data center capacity, you can rent infrastructure as a service on the cloud to do development and testing without a heavy investment, and then for seamlessly migration and compatibility, you can bring back and forth your development and testing environments from on-premise and from the cloud. Another very common use case is the web and mobile applications. You can develop this type of applications, both from traditional 3-tier applications with a web tier, database tier, or applications that has some components of platform as a service or mobile backend as a service. You can use vCloud Air for those type of application development. And finally, another use case is the cloud-hosted desktops. In vCloud Air, we offer a desktop as a service that companies can use to standardize on virtual desktops and use for streamlined IT operations. The 4 offerings that we have at vCloud Air is vCloud Air Dedicated Cloud, vCloud Air Disaster Recovery, Virtual Private Cloud on Demand, and Virtual Private Cloud. So in the next session, I'm going to talk about the difference between in the subscription service between the dedicated cloud and the virtual. The virtual dedicated cloud is when you have the compute service is dedicated for the user, and it provides a minimum set of RAM and CPU, and it offers the maximum isolation and resource consumption. The storage is shared as well as the network, and in those cases are logically isolated. In the virtual private cloud is where all the resources, both compute, storage, and network, are isolated logically, and those are the minimum capacities that customers can access, and from there customers can subscribe to higher resource consumption. The on-demand, the virtual private cloud on-demand offers the same capabilities as the dedicated cloud and the virtual private cloud, with the difference that it has a more flexible consumption model. Customers can instantly provision the compute resources that they need to use. It has a pay-as-you-go consumption model. Customers can register and immediately get access to the compute network and storage capabilities that they need, and they can seamlessly integrate with the existing on-premise network and applications and management tools. One of the benefits of this is that they don't need to invest on upfront resource and cost commitments. It's a flexible consumption, and it offers fully compatibility with the on-premise workloads and management tools. And finally, I'm going to review the storage options that we have at vCloud Air. The standard storage has a predictable performance, is a low cost, and some of the use cases that is good fit for is development and testing and DR. The next level is the SSD accelerated storage, where there is a high performance, and this is good for web applications and package applications. Then the next level is the guaranteed performance, which is oriented for low latency and high performance and databases, enterprise applications and databases. And finally, we offer the vCloud Air Object Store, which is extremely scalable, and it offers a capability to store files, backup, and unstructured data store at a very low cost. This is an overview of vCloud Air service, and I'm giving control back to Jim.
Okay, you can pass it on to Thiru.
Okay.
All right. Good morning, good afternoon, everyone. This is Thiru Panyala from VMware IT. So thanks, Paco and Jim, for the introduction on two different components, the Nirmata and vCloud Air. Both of these are important elements in enabling the DevOps. So today, I'm going to quickly walk through the journey that VMware IT went through in enabling a successful DevOps, and we are continuing to optimize that. So at a high level, here at VMware, we deal with number of scale and complexity issues. We got thousands of VMs in delivering our projects every year, and millions of lines of code. We deliver hundreds of projects and so on. And still, business always we want more, we want faster. So it's almost like a problem where business is trying to get their feature set to the end customer as soon as possible. However, our processes involves development and ops folks, and there is a path how these artifacts as developed by developers get all the way into production. And that's where we came up with DevOps operational efficiencies and how we're going to deal with the tool set and with the technologies that we have at hand. Sorry about that. All right. So there are as you see, the artifacts go through development, testing, and so on before they get into the production. However, what business is asking us to do is make this whole path short enough that it does not take just days and weeks, but instead it takes hours and minutes. So essentially what they are saying is build something called a wormhole. If you watched Interstellar, a shortcut to getting the features out into the customer world. So with that, how we can enable such a shortcut from the business feature definition all the way into a feature that's ready for customer to use. So we have to automate the build, integration, code quality, and infrastructure automation, including provisioning of the infrastructure and so on. So some of the key initiatives within VMware IT we have started are people transformation, process transformation, and technology transformation. From people perspective, we followed something called bimodal IT, where we have slow-moving processes and fast-moving processes. So the system of records or the systems of record have somewhat process nature to it that do not move as fast as we think or we want. So we separated the whole operational model into these two models, systems of record and systems of engagement. And then we have worked on various teams, including business system analysts and the development teams and operation teams, in transforming the people and the mindset coming out of their silo thinking within their own organizational responsibilities and come out and think broader and add towards the business goals of expediting the deliverables all the way from development into the production. From process perspective, we have optimized through continuous delivery and continuous integration with orchestration of the containers using Nirmata. We'll see a little bit more details around that one in a couple of slides. And from technology transformation perspective, we chose containers as our primary technology. Primarily, Docker is used heavily as a primary containerization technology within our infrastructure now. And we also have a number of other initiatives in the mobile and data transformation areas. So in enabling the enterprise applications for a faster delivery, there are a couple of speed breakers we had to deal with. One is how fast an environment is ready for the project teams, so they have the latest code from the production and latest configuration from the production. That gives them a great head start without having to think, how do I synchronize my code? How do I migrate my code? How do I merge that? So all those complexity will be gone when you have an environment that's completely ready with production refreshed code and configuration. The second speed breaker that we always hit is how the code moves from one environment to the other environment. This is a typical traditional SDLC process for most of the IT organizations. They start from the development environment and ship the code into test environment. Once the QA tests that, then they'll push it into user acceptance test and so on. Until it reaches production, there is a huge delay. And this is yet another speed breaker for enabling faster delivery into production. So what we have done is we looked at these two elements and we looked at the industry-wide solutions in the container space, and we came up with specific criteria for us to choose the right enterprise application and right candidates for containerization. The primary reason why we had to go in this direction is if you have a brand new greenfield application, it's pretty easy for someone to make the decisions on containerization versus any other technology in defining the architecture to make it continuous, deliverable, and continuously integrated. However, when you have an application that's existing and is in use, it's like changing the tires on a running car. So you have to consider what are the best applications out of your enterprise apps portfolio to pick. So some of the recommendations we came up with to choose the right candidate application for containerization is pick something that has higher frequency of development, which means it goes through continuous improvements in that application. That gives you the value for the buck and the effort that you're spending in containerization, because containerization initially takes effort from both development operations organizations. And then make sure the business and mission criticality of this application is not way too high to start with. If you pick something that's heavily mission critical and business critical, then you may be dealing with additional challenges, and you may come up with challenges in enabling containers versus dealing with the customer problems. And make sure the scalability of your application is high. That makes a good candidate for containerization. And the next one is, how do we pick the services within an application for containerization? Now, when you have an enterprise application, it's a composition of number of different disparate systems. Some of them talk to enterprise resource planning or ERP systems. Some of them talk to CRM systems. Some of them talk to external SaaS systems. So all of these in a composite way make an enterprise application. So we have to pick the right set of services in this composite application, with the service footprint being, light both at the build time and run time. The reason for that is, if you have a huge footprint, then you'll be spending more time in optimizing that footprint as opposed to actually containerizing the application services. And when it comes to environments, we decided that we start with development environment first. Once we validate that through the development environment, we'll move into the test environment. So we'll see quickly how we approach this overall process here. So we took a three-step approach for containerization. One is, first, Dockerize. You put the Docker files, define them, and design the Docker files with modularity and isolation in mind. Then field test those, which means you subject these Docker containers with a live project. That way you will understand the real implications of running a containerized application through a live project, and then operationalize that particular containers, which means, how do we monitor, have your operations teams come in and take a look at how do they monitor, how do they manage these containers, and what if something goes wrong. All the orchestration needs and scheduling needs are addressed as part of the operationalize. So at a high level, the process is going to look something like this. The application services, we pick specific services and we test them in the lab environment. And once you have these services passed in the lab environment, you will field test them on real life projects on the development environment. Once they are ready, pass through a couple of projects, then you will operationalize from operations perspective, manage it, and monitoring requirements and so on. Then you have the containerized services that are graduated and ready for prime time. And then subject this to your next SDLC environment, QA or test environment, and UAT environment, and so on. So that's how you will mature the container services all the way into production as you evaluate the risks as you go through development, test, and stage, and so on. So in our particular case, we have done a couple of minor applications, one internal facing and one external facing VMware blogs. So if you are looking at VMware blogs, that's running on containers. So we went through the experience of what it takes to containerize and schedule and orchestrate and so on, what tools are the best choices for enabling containerization. And then we picked one of our biggest application called MyVMware. Most of our customers and prospects have access to MyVMware, and our product and support related activities are performed on MyVMware. So MyVMware architecture includes front-end services, middleware services, and internal systems and external system dependencies, and so on. So as part of our guideline, we did not want to containerize every single component of these because they are not container friendly in some of these areas. And even if they are container friendly, the value that we get out of them, out of each and every component, may be slightly different. So we had to pick and choose the key services that we want to pick for containerization. In our case, we picked LifeRay on TC server and Gemfire with JDK and Oracle Service Bus. Just to give an idea, LifeRay is the portal component that's facing the customers. So anybody who logs into my VMware will first land on LifeRay portal. And Gemfire is our caching management server, and Oracle Services or Service Bus is our endpoint virtualization service. So with these components, we started with development environment for containerization. Once we felt comfortable with these services running smoothly, and we executed a couple of tier 1 projects on development environment, then we moved on to test environment. So in the process of this, if you notice, we have an application that's partially containerized and an environment that's a hybrid of containerized and non-containerized environments because of the way we wanted to take this in a staggered approach. So that brings a couple of challenges that anyone who is intending to containerize enterprise applications need to be concerned about. So the challenges are, as you see here, you have a bunch of containerized services and non-containerized services, and also you have external dependencies. The question is, how do you make sure the containerized services can understand and talk to external non-containerized services, and how the containers themselves know which environment they are serving, so they exhibit that identity in that environment. For example, containers have no identity. They run as any environment as long as they have compute and bandwidth and network resources. However, with the combination of non-containerized services and external dependencies, we need to carve out the specific dependencies from your enterprise application and make it a central repository for all sorts of configurations. That's going to help you with modularizing the application. And Nirmata provides something called dependency injection through environment variables and various other methods that helps you at runtime inject the dependencies you have across the environments and within the application. So this next one talks about how do you move the artifacts, development artifacts, from a containerized environment to a non-containerized environment. So we did something called configuration files and initialization scripts that will get started with Docker containers. So that's how we enabled an enterprise application with traditional integrations with all the internal systems and external systems, and containerized them and brought them to a level of operation where enterprise application can also be working in a modern containerized world. So far, what we have done within VMware IT is we have Dockerized LifeRay, TC Server, Gemfire, Enterprise Service Bus, MySQL, Nginx, and PHP as part of our application stack, including our internal wiki and VMware blogs and a partial stack of MyVMware. And this is still continuing, and the benefits that we got so far is we have, for the containerized applications, a portable code and a portable infrastructure. Portable infrastructure, what we mean is you can pretty much deploy this application on vCloud Air or private cloud or any of developers' laptops. That's as portable as that. And the next benefit we got out of this is it provided us a way to define infrastructure as a code. What that means is your infrastructure is no more, oh, I don't know what kind of patches I applied, what kind of security patches are out there, and the configuration management across different nodes in the cluster. All of those are now described in the form of a file, and they are available for versioning and so on. And the final benefit here is self-service capability for infrastructure. So development team can go in there, self-service, create their own environments, and move on. This probably we'll see in the next demo on how these capabilities are enabled. With that, let me pass it on to Ritesh. Is that you?
It would be
Jim?
me, Jim.
Yes, guys. Jim, before we begin, I wanted to just take a quick moment. We had prepared some poll questions for the audience, and Jim, I think it would be nice if we had an idea of what our audience is, where they are in terms of container usage and what their goals are. So would you mind if we just took a quick moment and jumped in on one?
Sounds great.
Okay, so here's our first question, and it's, are you using containers now? And real simple, yes in production, yes in dev test, no, but we're interested, no, maybe in 6 months, or we currently have no plans. And if you can just take a moment to answer this, I think it'll help Jim kind of figure out where we are in our audience. We'll do another 5 seconds here, 5, 4, 3, 2, 1. And I think we can see the answers come up pretty quickly. And I guess as we'd expect, we're not seeing as many in production, but certainly we're seeing a sizable amount in dev test, and we're seeing a large percentage of people who are interested, and then a very small percentage of people who, have no plans to use containers. So, Jim, that's probably in line with other polls we've seen. Let's grab another question if we can. Which of these best describe your primary goal for adopting or considering containers? And you can select more than one here, guys, so I would imagine there is more than one goal. And again, if you can take a moment to make your picks, we don't want to waste too much time. So we'll just do, I don't know, another 5 seconds should give everyone time, I hope. 5, 4, 3, 2, 1. Okay, and our answers here. Ooh, rapid software agility. That's right, in the DevOps mode. Improved resource utilization was third, and second was adopt DevOps or microservices. So, interesting questions there. And I think we have one last one here, guys, if we can jump on it. And that is, what are the top challenges you face or are likely to face when adopting containers for DevOps? And here are the answers. Lack of simplified container management and ops, lack of seamless end-to-end DevOps automation, security and governance challenges, always popular, and then the lack of integration with my existing infrastructure, and again, lack of integration with my cloud provider. And again, we'll just do about 5 more seconds here. 5, 4, 3, 2, 1. And looks like the top 4 was certainly pretty close to each other, but lack of integration with existing infrastructure and lack of simplified container management and ops were the leaders. But all the top 4 are all pretty close. So, Jim, I hope that helps you in terms of framing up the demo where we're going to present. And
it does.
I'll turn it back over to you.
Thank you, Ellen. Yeah, it certainly helps. Very insightful. And so what I'll do, and I'll try and address some of those, especially the container management and integration aspects of what we just learned. So what I wanted to do in this last segment before we go over to Q&A is show a brief demo of the solution in action, right? So here I'm logged into nirmata.io, and what I'm seeing is a quick dashboard, a summary dashboard, if you will, that just shows me, what I have on my system right now. So a few concepts to highlight. In Nirmata, applications are modeled in Blueprint, and each application can contain one or more services. So within a single blueprint, you could have several services or a few services based on the complexity of your application. And then when you run these applications, you run them in different environments. So you may have environments for dev test, staging, for production, for different regions. It's very flexible. You can define your own environment types and have as many of these as you wish. At runtime, Nirmata allows you to onboard your own cloud providers, as well as once you have your cloud providers, you can further segment your resources into something we call host groups, where you're defining pools of similar resources based on either functional aspects or non-functional aspects. So you can allocate a pool of resources or a host group to a team. You can allocate it to a service, for example, if it's an edge service, or by, again, any other rule or mechanism that you wish. So this is the quick setup, and as you see, we already have quite a few cloud providers, including vCloud Air, other cloud providers. We have a private vSphere system connected in here, other public cloud providers, and we already have some host groups defined. So what I want to do is I'm going to switch over to a developer and DevOps view just to quickly show what the end state is going to look like, and then we'll come back to some of the details in the product itself. So here I'm showing a build pipeline, which is something we've set up. We use Jenkins for our builds, and what we've done is we've fully automated everything from a commit to taking, building the container images, to taking that container into your first, perhaps a test environment, running through a series of feature and integration tests, and then automatically promoting or demoting that container to the next environment in your pipeline. But what I'll do, and inside each one of these Jenkins tasks, what we're doing is we're leveraging the Nirmata REST API to automatically spin up environments, containers, services as needed. So here I have a very simple REST API. I'm going to do a post operation on Nirmata.io's API, which says provision a new environment. I'm going to give my environment a name. I'm going to select an environment type and an application blueprint that I want to provision this with. And once I send this request, I get back a response, but if I flip over to Nirmata, what we'll see is in my environments pane, there's one environment which is currently being provisioned. This is Nirmata East. Most of the services are already up and running. So it's incredibly fast, takes a few seconds. And there's a lot of work, of course, that happens behind the scenes. Nirmata figures out which cloud providers, whether there's available resources, if there's dependencies between the services, what the service affinity rules are, a lot of details. But what you get as an end result of all of this is based on your policies and based on what's said over here, now my application is up and running in a few seconds. So really, it can be that fast, that easy with the right tooling and the right systems in place. If you notice, this application was deployed on vCloud Air itself. So if I drill and I switched over to see the host group view of where this was deployed, I see that on my particular this host, I have about 6 or 7 containers running. I can move back up a level and look at my entire host group on vCloud Air, which is a dev test host group. And I see I have about 15 or 14 containers running in all over here, and I'm about 80% utilization for my memory. But let's step back and see how did this all happen, right? So for the developer and for my integration tools, whether it's Jenkins or vRealize automation, extremely simple, extremely easy. Just give your environment name, select the type, and there's a bunch of things that happen. But how was this set up in the back end? So I'm going to flip to a getting started view, which is what you would see if you go in and first, if you self-sign for Nirmata's free beta, what you'll see is this view. And at this point, you have the ability to add either a single cloud provider like vCloud Air, or you could select, even just your an available host. This could be a VM or a physical machine or even your laptop that you want to attach into Nirmata and have it manage and operate containers. The next step would be to define these host groups, and this varies a little bit based on the type of cloud that you select. So if it's vCloud Air here, we would provision or we would query the vCloud Air APIs to be able to look at the virtual data centers that are available and the templates and flavors of VMs that are available for provisioning within this particular cloud provider itself. So very easy to set that up. And really that's it. As you know, to start deploying containers, that's all you need. Because at this point I can start either importing applications from an available image registry, or I can start modeling my own blueprint, and I can start defining how I want these applications to be deployed. So here I'm showing the public Docker image registry, and it's very easy. So say I want to create a new Tomcat service. With one click, I'm now creating a Tomcat service from an official repo. But let's go and look at some of the more custom, more complex applications that you can also model, and how those are set up within Nirmata itself. Because like we heard from Thiru, one of the starting points for containerization may very well be a brownfield application, which could have several dependencies, internal and external. So here we have several different applications, and if you notice, even Nirmata itself, we have containerized and can deploy with a full click, with one click of a button. We have a experimental OpenStack blueprint that we also have fully containerized and can automate the deployment of. And here I'm going to select, the application we deployed and show very quickly what the internals of the blueprint look like. So we have a few services here, and in these services we have different, aspects of my storage, my networking, my routing for my services, whether I want service discovery enabled, a number of different parameters configured, and of which perhaps the most important is the image name, and the tag, the version that you want to use for your particular service. But once you define those blueprints, and you can also, like Thiru was mentioning, Nirmata allows dependency injection across services, so you can define environment variables, externalize your configuration. It's now your entire blueprint is ready to deploy with a single click, just like we did from the API. So I'm going to quickly go back to the running environment, and I want to show a few things there. But before I do that, in fact, let me show you another policy that you can set, which is extremely powerful and useful in a hybrid cloud environment. So if you notice, when we invoked our API, we just said, I want an environment of type sandbox. So what happened here is we have a number of different environment types, and once again, you can create your own environment types. So we have some called demo, sandbox, production, staging, and Nirmata environment type. And sandbox here is mapped to a particular host group. So what this lets us do is we have two rules for sandbox, and here we are saying if a user requests a type environment of type sandbox, I'm going to select vCloud Air and a particular host group on that. If I'm out of capacity on that host group, Nirmata can also have a fallback policy or rule where you can put that the environment of that type on a vSphere system. So very easy to make that entire application portable and now usable across multiple clouds. So one last thing I want to show, and I know we're close to about 5 minutes left, so I'll wrap up the demo quickly, but one last thing I quickly want to show is as we are, first off, as we're, we were talking and collecting data, there's full analytics available on every container, every aspect of your system. But not only that, but Nirmata here, what we have the ability to do is if you remember I mentioned that you can also have built-in microservices style operations. So what I'm going to do here is I'm going to, for let's say this order service, I have 3 instances already provisioned in this environment. So I'm going to pop up a couple of services, and these are very simple, services which we are using for testing purposes. So they are Tomcat Java services, which we can, which just display the IP address and port where they're running. And what I'm going to do is from my recommendation service, I made a DNS call to orders in my application itself. And Nirmata automatically, without doing any additional provisioning or management, was able to configure or resolve that service to an IP address and port. So at this time, if I continue making these calls, if you notice it's load balancing also because I have multiple instances of that order service running. Similarly, we can deploy an application gateway and get the same type of functionality if we wish also at the application level. So other things that we have is, again, if you're looking at your physical or your logical view, very easy to get your overall utilization, easy to manage resources across clouds, and really get to that level of agility and DevOps that we as an industry and as a group want to achieve. So I'll stop there and pause for any questions.
Okay, thanks, Jim. Well, we do have a bunch of questions here, but unfortunately not a lot of time, so we'll do the best we can. So question to Jim. Are you seeing customers run their production workloads on containers like Docker, or containers are still more for the dev test environment?
It's a good question, and the starting point certainly is dev test. So like Thiru demonstrated in his use case and talked about, dev test is a great place to start, but very quickly, and especially for the sort of some applications, the greenfield applications, we're seeing that extend to production as well.
Yep, excellent. Next question from Javed Patel. What container orchestration tool do you use or recommend?
So I can start with that. And
Gotcha.
yeah, so certainly we, being part of Nirmata, we think Nirmata is the best tool for management and orchestration across cloud. But would love to hear from Thiru and how his team evaluated and looked at these tools.
Sure. So thanks, Jim. The key three things that helped us decide on the orchestration tool is, the nature of the tool itself, how intrusive is it in our containerization process. So Nirmata, we found it's pretty non-intrusive in enabling policy-based scheduling and orchestration. And the second thing is, it's got the best user interface with clear role-based access to container management. And the third one is, Nirmata has great integration with VMware technologies, vSphere, vCloud Air, which is both private and public and hybrid clouds. So that kind of helps us figure out how our loads are going to be distributed depending on our policies, depending on our needs and resource availability and so on. So for these three key reasons, its nature being non-intrusive, and it's pretty quick, just in a minute you have an orchestration tool ready to go, and its interface with segregated roles and responsibilities in managing the containers, and the third one being best integration with the VMware technologies.
Excellent. Okay. So how is Nirmata different from other open source container orchestration solutions, such as Kubernetes and Mesos? Excuse me.
Great question. And so there, what we've done at Nirmata is we wanted to provide a managed service that's really easy to use and non-intrusive, like Thiru mentioned. So this Nirmata itself is run as a cloud-native service, so you don't have to do any installs or operations or management. So it's one thing to get a tool deployed and the initial deploy, but to operate and manage at scale and provide 24/7 support and SLAs around it is where Nirmata provides value. The other aspect I'll quickly highlight is the multi-cloud container plane. So most of the other solutions you would install, operate, and integrate with each cloud provider separately. So you end up with different panes of glass. Nirmata is a single pane of glass, single control plane, same policies, same blueprint across any cloud.
Excellent. Next, another question from the audience. Can you explain use in network automation and validation using microservice and containers?
Yeah, so microservices certainly add a lot of stress or some requirements on the networking side. And what we're seeing is the patterns that we use in a data center before, like load balancing and routing, now are done in the application and software layer. So that's where Nirmata provides, the integrated microservices, the service discovery, resolution, name resolution through DNS, as well as load balancing at the application layer. And the intent here is to fit in with existing load balancers, whether it's using at the edge based on the cloud provider that you're using, and then use your application service gateways and load balancing within the application would be handled by the microservices infrastructure components in Nirmata.
Excellent. Guys, we're at the top of the hour, and it's not nice to make people stay later. Everyone, I'm sure, is busy. So I'm going to take this time to wrap up. I think we've answered 98% of the questions. There was a question about a certificate of presence, but I'm not sure if we've never really done that at webinars. There's not a CPE credit or anything. But in any event, Paco, through Jim, thank you very much for a great presentation today on containers and for helping us here at DevOps.com as we continue our webinar series. Thank you to Nirmata for sponsoring today's webinar, and to those of you online, thank you for attending today. This is Alan Schimmel for DevOps.com, and we will see you again on our next webinar.